Hello everybody, welcome back. This is the second part of my video sequence here on decision making structures or selection structures. And in the last, I should say that the first part of this series, we spent some time just looking at the fundamentals. We talked about what a condition is and the fact that selection structures always have a condition. And if the condition is met, the block of code will be executed in the if statement, and then the structure basically looks like this. We have if, and then some condition which may or may not be in parentheses, that's up to you. And then the word then, and then inside of the block, which would be line 8, this would be the code that runs if the condition is true. So that is the first type of statement we looked at. This is a single alternative statement. It's either going to execute this or not. We looked at the dual alternative, which gives you two execution paths. So in this particular case, it's either going to run the code on line 8 or on line 10. And when I say line 8, it's really any code you put between lines 7 and 9, and then lines 9 and 11. This block, this area here. You will note here that I always indent the code inside of the if statement. Now, you'll see this convention used in pretty much any programming language, but that's something to just keep in mind. It's important to indent just for readability's sake. It's just easier to follow the code when you do that. If you don't indent the code, it's just more difficult to try to parse through. So get in the habit of doing that indenting if you haven't already been doing that. It's something that you're going to want to learn and just kind of have it become second nature after a while. The other thing that you want to take a look at is the flowcharts. In the chapter in the book, there are flowcharts that are presented for the single alternative and the dual alternative conditions, and then they have some other examples with flowcharts in them. And personally, I'm not a real big fan of flowcharts. I prefer pseudocode. I like to just basically type in all the steps that I need to do in my program and then to start writing the code for each step. But a flowchart is a viable alternative. It's a way of looking at your program in a symbolic way, and it does help a little bit to understand the flow of the program. And so as for instance, when you have an if statement, you'll notice that the question is placed inside of a diamond, and then a line goes in off to the left and off to the right, and then you can follow that flow either direction, and then you can just get a better sense graphically of how things work in the code. So as I say, I'm not a big proponent of flowcharts myself. I just find that it's a lot of work to put them together, and for me pseudocode is a viable alternative. But for you, especially when you're starting out, you might want to consider putting flowcharts together. I'm not going to require them in any of the assignments I give you, but again, it never hurts to try to create one if it helps you out understanding the code. The other thing I wanted to talk about here is some of the different relational operators that you can use when you create your conditions. And I'm going to switch over here to Small Basic to show you this. What I have here is a program like similar to what we did in the last video. I ask the user what their age is, and then I get a number from them. And I look to see if the age is greater than 70, and if it is, then I'll do something here in the code that doesn't really matter right now. I just want to focus on the relational operator part, this greater than sign. If you need to check, for instance, if the if the person was greater than or equal to 70, you would use this approach, the greater than sign followed by the equal sign. If you've worked with algebra and you understand that there's a greater than or equal to symbol where there's a line underneath the greater than sign, well, there is no such keyboard character in programming, so we have to put a greater than sign and then an equal after it to sort of replicate that symbol. And you have less than or equal to, and then just simply greater than or less than. Now, here's a little bit of a difference that you'll notice with small basic versus other languages. And this actually is really true of any basic language variant versus any other language. So in basic, when you want to check for an inequality, you use a less than greater than sign like that. So this reads, if the age is not 70. Now, let me just go ahead and test this. Kind of a silly program to write, but just to illustrate the concept here. So what is their age? If they put in 70, it doesn't run the code because the only way it's going to run it is if they're not 70. So now if I put the age in and I put 60, it tells me you are not 70. So that's helpful. Okay, anyway. In just about every other language I've worked with, and this would include C#, C++, Java, JavaScript, the inequality symbol that's used is an exclamation point followed by an equal sign. The exclamation mark in programming stands for not, or a negate operator. It's a logical operator. Not is followed by the equal sign, which reads not equal. But if you do that in small basic and you try to run it, you get an error. So you're going to learn this approach, but when you use other languages, so say you take this course, then you follow this course with 117, so you get into Java programming, you will be used to using that symbol set, and you'll have to switch over to using this symbol in other languages. The other thing you're going to be forced to do is to put the parentheses around your condition. So you might as well use parentheses and just get used to doing it, but you don't have to. But again, if you're going to use any other language, you'll need to do that. So just an FYI on that. Another difference is when you test for equality. In most languages, they use a double equal sign. Now, why do they use double equal? Well, the single equal sign is considered an assignment operator. In other words, you're telling, I shouldn't put this in the code because it's going to freak out on me here. Let me switch over to my text editor. A single equal sign is known as an assignment operator. So x equals 3. You're telling the program x should be 3. A double equals is an equality. It's really a relational operator. It's comparing. So it's asking. You're asking the program if, I can't type here, if x is equal, I'll just say if x is 3. So one equal sign, you're assigning or telling the program x is going to be set to 3. Or I want to set it to 3. Okay? At two equal signs, you're asking, is x equal to 3? So there's that distinction in most languages. In BASIC, you always use the single equal sign, and the compiler, or the interpreter actually, figures out what your intentions are by looking at the context of the code. So I'm just going to put a note. In all other languages besides BASIC, you have a single and a double equals. And I'm just going to put here not equals while we're at it. In BASIC, the equal sign can be either an assignment operator or a relational operator, depending on the context. So what's nice about that is that you don't have to worry about putting one equal sign or two. But you're going to get spoiled because when you get into Java or some other language, you're not going to have that anymore, and you're going to have to use either one or two equal signs, depending on what you're doing, whether you're setting it to 3 or testing it to see if it is 3. So that's something to keep in mind, just as an FYI. And here I'll put the not equals in here too so you can see this. So those are just some differences that you're going to run across when you work in other languages compared to a small BASIC. In this case, if I try to use the double equal sign, it's not going to let me do it. It's going to say I don't understand that. So I'll use the single equals, and then of course it runs, so just some things to keep in mind. Let's take a look at logical operators and talk about that for a bit. There may come a case where you have two things you want to test. So right now here we have an age, and let me switch this back to, let's go age less than 10, and let's say that you had a situation where you wanted to give a discount to your customer if they were less than 10, let's say less than or equal to 10. If they're less than or equal to 10 or 10 or under, okay, we want to give them the discount. And also, if they're 70 or greater, we want to give them the discount. So 10 or less, discount, 70 or greater, discount. How would you write that? Now, one way you could do this is to do what's called a nested if statement, but it's a lot of extra code. What's better to do is something like this. This is a relational operator, the OR statement, this OR keyword right here. And the way this reads is, you have this test right here, and you have this test right here. There are two tests going on. When you see an OR, that means only one of the tests has to be true for the condition to pass or to be true. So if age is less than or equal to 10, it passes. If age is greater than or equal to 70, it passes. Now, if they're both true, it also passes, except in this case, you couldn't be less than or equal to 10 and be greater than or equal to 70 at the same time. So you would never have a case where both would be true, at least in this example. But if you did, it would pass. The only time it would fail is if both expressions were false, which would happen like if the user, say, was 30. So if you're 30, this statement is false. 30 is not less than or equal to 10. 30 is not greater than or equal to 70. So both conditions would fail, and it would not pass. It would skip over line 5. That's a logical OR. And it says on the right, if you look over here, it returns true if either one of the inputs is true. Now there's a second type of logical operator called an AND operator. This second way of doing this would, again, have the two tests. With the AND operator, the only way this is going to pass is if both questions are true. Age has to be greater than 10, and age has to be less than 70. Did I say greater than or equal to? I'm sorry. Age has to be greater than 10, and age has to be greater than 70. Both have to be true for you to jump into the block of code, which should be line 9 in this case. So, if the person was 30, age would be 30. 30 is greater than 10. 30 is less than 70. Both conditions are true. It would go in and tell them they didn't get a discount. If one of the conditions is false, that knocks you out of the running. If they're both false, that knocks you out. The only way you're going to get in to the code is if both are true. With the OR, only one of them has to be true. So which one you use depends on the problem you're trying to solve. The only thing you have to be careful about is that you use the correct operator. If you look at line 4, a person could very easily come up and say, we want the program to give you a 10% discount if the user is 10 or less and if they're 70 or greater. Notice I used the word "and" in that statement. That actually is technically that is incorrect. What I should have said is if they're 10 or under, or if they're 70 or above. Sometimes when we speak to people, we use the wrong logical operator. And we can figure it out in our minds. We can kind of compensate for that inaccurate statement kind of automatically. We oftentimes don't even think about it. But a computer can't do that. It's very precise. Everything has to be right. And if you type it in the wrong way, you'll have what we call a logical error. The program will compile and run, but it won't work the way you want it to work. So the general rule of thumb is, if you have a situation where only one thing has to work to pass, use OR. If both things have to pass to work, then use AND. And by the way, it doesn't just have to be two things. You could have 3 or 4 or 5 things in here if you wanted to. So for instance, I might say has card is equal to 1. Maybe they need a discount card or something to carry along with them. So either they're 10 or less, or they're 70 or greater, or they have a card. And if any of those are true, they get a discount. So my point is simply that you can test more than 2 conditions, as you can put in as many things as you want. The rule still works the same way in that particular case. So those are logical operators. There's another one called the NOT operator. What that would basically look like would be something like this. If not has card. Now, if I try to run this, you'll notice that it has issues with line 12. Small Basic does not recognize the NOT operator. The only logical operators it recognizes are AND and OR. It does not recognize NOT. So NOT is essentially a negate operator, and that really applies to what we call Boolean variables, which Boolean variable is either true or false. Small Basic doesn't have Boolean variables. It just has numbers and text. Has card, if it was a Boolean, could be set to true or false. Not just simply flips the Boolean. So if not has card, If has card is true, not makes it false, and vice versa. So the concept is pretty simple. It's just that in small basic, they just didn't bother to implement it. And so it doesn't have the not. It just has the and the or, which 90% of the time is what you would use anyway. I usually don't use not very much at all in the programs that I write. Every once in a while I will, but not very often. So technically there are 3. In small basic, we're only using 2 of the logical operators. And as far as the relational operators, you have seen greater than, less than, greater than equal, less than equal, equal, and not equal. Those are all of the operators there. Those are all relational operators. And then you have and or are your logical operators. So those are the things we work with inside of the parentheses if you use them, or when we build our conditions for our if statements. So I think I'm going to close part 2 here, and I'm going to do a third part in this sequence of videos. And in the third part, I'm going to just run through a couple of examples, just kind of putting together all of the stuff we just talked about. And if I do that now, I think this video will go a little bit too long. So I'm just going to go ahead and make a third one, and I'll do some examples, and that'll wrap things up for this particular topic. So we'll see you in the third part. Thanks for watching.